Hello, everyone. This is Japheth, and he's going to talk to us about a bit about linear algebra. So, first off, Japheth, thanks for joining us. Can you tell everyone a bit about yourself? Like, when did you come to Lee, and what did you do while you were here?
Yeah, I came to Lee in the fall of 2017, and when I came to Lee, I started off as a double major in math and music. So the first couple of years, I was really just taking music classes. Then halfway through my sophomore year, I started taking math classes, and then after that, I was pretty focused on math for the most part. Eventually, I dropped the music major down to a minor, and so I finished with just a math major and then a couple of minors actually. Um, I also took some computer science classes. So I would say a lot of what I did while I was at Lee, the first half, a lot of music stuff, like playing in ensembles. I played an orchestra, I think for at least, I think 4 years. I played an orchestra. I did a lot of jazz band. There was like a small jazz ensemble when I got there, and then I moved onto the big band. Was playing in that for the rest of my time at Lee. And then with math, um, I did a couple of for fun projects, uh, which are actually related to linear algebra, so maybe we can get back to that later. And then I did some summer research programs, so some REUs, if you all have heard of that. So that's roughly what I did while I was at Lee.
Well, thank you. And what was the first thing you did after Lee?
Uh, right after Lee, I went to grad school. So I ended up going to Wake Forest for my master's. I think actually here, yeah. Here's my proof that I went there.
Congratulations.
And yeah, I don't think I did anything during the summer. I think I just relaxed during the summer, and then when I went to Wake Forest, that's when I started hitting the books hard again.
And what did you study at Wake Forest?
Right, I studied math. More specifically, I studied computational number theory. So this is like solving problems dealing with elliptic curves, and using like the computational tools that people have developed to try and solve those problems.
And even though you did, a relatively abstract form of mathematics in grad school, what's your current profession?
My current profession, I work for a cybersecurity company. I work as a cryptography researcher. Yeah.
Well, thank you. Kind of taking you back to 2020 when I had you in linear algebra. What was your first
Right.
impression of linear algebra? Like in those first, a few weeks, few months of class, what was your first impression?
Yeah, it's hard to. I mean, that was COVID, right? So there's that going on. Um, no, but I want to say I enjoyed it. I mean, by that point I had already started. I think I was somewhat familiar with some of the applications in video games and just like uh, graphics stuff in general. So I already had sort of some motivation to learn more about the topic. Yeah. But then COVID did make it a little tough in the second half of that class for sure.
I remember. I was there. Well,
Yeah.
that's good news for all the e-gamers in the audience. But what are like a few contexts, now that you've taken uh, linear algebra, you graduated, you moved on to bigger and better things. What are some areas where you did see linear algebra rise after you took the class, either in other math classes or in your work?
Yeah, linear algebra pops up all over the place. So in other math classes, maybe I should just talk about in work because that's maybe the more applicable part of it. So So cryptography is this area of research where we're trying to look for methods to send messages in a way that only me and the person I want to send the message to can understand the message. No third party that's listening in on the conversation would be able to understand. That's the goal. And typically you are doing things like, scrambling a message in such a way that, your friend can reverse that scrambling, but a third party can't do it. That's one of the ways you would do this. And one really popular algorithm for doing this, like a standard algorithm, I should say, is AES. It actually stands for the Advanced Encryption Standard. And so you can look this up, NIST, NIST, AES, and they'll have a specification of the standard. But part of the algorithm is this, the scrambling bit that you're doing. Part of it involves a linear operation, a linear transformation. So you view your data as like a vector of not quite numbers, it's polynomials, but I don't think we have time to really get into that. But a vector of these values, and then you apply this linear transformation to that vector, and this, in a way, does a kind of scrambling of that information. You have to do other things because linear transformations are not the most secure operations, but you do a few other things as well. But a linear transformation is a big part of it. So you can actually write down a matrix that you use to perform this transformation. And I'm sure there are other places in cryptography that use linear algebra. That's just one example.
Well, thank you. I know there are many more examples, and I think that the students will hear from a few other former students. But, what do you think are the most important takeaways, or one of the most important takeaways from linear algebra from that first class you took?
I think the most important takeaway for me has been just the way I organize large amounts of information and just the idea of like, okay, put it into a vector, and then that opens up this world of linear algebra where you have all these tools at your disposal to work with that information. Like I said, for example, there's applications in video game design, really graphics design, and I remember one of the first problems. Well, one of those side project that I had talked about earlier. I had talked to Dr. Schmer about this, and it was if I drew like a shape on a page, and I wanted to tell a computer, fill up this shape with triangles. Make triangulate it in such a way so that maybe you have like you're just drawing lines between the vertices of the shape. So I'm thinking of a polygon, and the result is that this polygon is now a bunch of triangles. How do you tell a computer to do that? And there was an application of linear algebra. You could think of the vertices. You could describe them using a point on the real plane, and then now going between two vertices, this is giving you like an arrow, which you think of as a vector. And then if you want to decide whether or not you're within the polygon or outside of the polygon, there's this cool trick you could use the dot product to figure that out. So I think just that way of thinking about data, like these these vertices, or in the case of cryptography, right, you're dealing with usually very large amounts of data. You got like a huge a huge text file or something, and that gets them converted all to a bunch of zeros and ones. How do you organize that data? And the tools of linear algebra are really useful for helping you organize and work with that kind of data.
Thank you. Last but not least, Japheth, what advice or words of wisdom would you leave a beginning linear algebra student who is uncertain of, how they should approach or why they should approach the class with, intentionality?
So are your students, are they all doing computer science as well, or is it the kind of half and half?
The whole spectrum: CS,
Okay.
math ed, engineering.
Man, if you're into programming, or if you're interested in programming, I feel like picking up some programming and then kind of taking that to linear algebra, like trying to implement these algorithms that you learn about in linear algebra, or these operations, really, like dot product and stuff like that, implement them in code is like a really cool way of motivating yourself to learn about this stuff. And you really do learn it. Like, I think if you can write a program that does the thing that you would normally do by hand, you've like learned that thing pretty well. That's like how I would motivate myself to do these things. And then you kind of are building up your own calculator, your own linear algebra calculator. I think it's cool.
Well, that's pretty cool. Well, for the purpose of this video, thank you, Japheth. I will send students your way if they have any more questions, but thanks so much for this.
Yeah, no problem. Thank you, Dr. Moy.